In this lecture, we are going to see one more application of op-amp, that is op-amp as a zero crossing detector. So far we have seen what all applications: op-amp as summer, that sums the input voltages given at the input. Then we have seen op-amp as subtractor, that subtracts the input voltages. Then we have seen op-amp as differentiator, that differentiates the input signal and gives it the output. Then op-amp as integrator, we have seen that integrates your input signal. Now in today's lecture we are going to see op-amp as zero crossing detector. Now as the name suggests, we understand that zero crossing meaning it will detect when the op-amp's output signal is crossing the zero. Okay, this is basically a comparator. Okay, this is how the circuit of zero crossing detector is connected, and it is basically a comparator. Now what do you mean by comparator? Comparator meaning it compares between two input signals. Okay, दोन inputs compare करता. Now which are the two inputs here? One is negative, that is your inverting input. Second is positive, that is non-inverting input. Okay, there are two diodes connected here for current safety. Now to the input, the inverting terminal of the input, there is one resistor here for current safety, and there is one input signal given here as Vi. Okay, this is connected to, Vin is connected to negative terminal. To the positive terminal, there is another input connected, which is called as reference voltage, given as Vref. So reference voltage in a zero crossing detector is taken as 0 volts. Okay, this you have to remember, that the main point here is that the reference voltage in a zero crossing detector is 0 volts. Now in this circuit, the input Vin is given at the inverting terminal. So what configuration is this? What configuration of op-amp is this? This is inverting configuration of op-amp. If the input voltage was given at positive input terminal, the op-amp configuration would have been non-inverting configuration. Okay, हांगासर input voltage आसा ती negative terminalak दिला or inverting terminalak दिला. That is why this is inverting op-amp configuration. Okay, now here I have explained you, in this video I have explained you op-amp as a zero crossing detector in inverting configuration. For IT I will ask op-amp as a zero crossing detector in non-inverting configuration. That time what are you supposed to do? Everything will remain the same, only this input voltage will be given to positive input terminal and the reference voltage will be given to negative input terminal. Okay, so that you have to see. So what is op-amp as zero crossing detector? It is basically a comparator that will compare between the input voltage given at positive input terminal and the input voltage given at negative input terminal. In a zero crossing detector, the reference voltage is always equal to 0 volts. The output will be taken here at pin number 6 at this resistor RL. What is plus VCC? This is positive saturation. What is negative VCC? Negative VEE minus VEE. This is negative saturation. Okay, this can be plus 15 volts, this can be minus 15 volts, or this can be plus 12 volts, or this can be minus 12 volts, whatever voltage you want. Okay, then let us see how this op-amp as zero crossing detector operates. Okay, what is the basic operating principle? The basic operating principle of zero crossing detector is that if Vin is greater than Vref, okay, Vref म्हटल्या खंयचो? Vref म्हटल्या 0 आणि Vin म्हटल्या वो. If this voltage value is greater than 0 volts, हांगासर suppose 0 च्या चड आसा, जाल्यार what will be your output? If Vin is greater than Vref, then Vout will be equal to minus VEE. Minus VEE म्हटल्या वो. Whatever is this value will be your output. Now why is it happening that when Vin is greater than Vref, why are you getting Vout is equal to minus VEE? See here, Vin is connected to negative input terminal and V reference is connected to positive input terminal. Now here in this case V in is greater than V ref, meaning the voltage connected to negative input terminal is greater, and because of that the negative saturation voltage, that is minus VEE, is your output. Okay, clear? Then second case will be if V ref is greater than V in. If V reference is greater than V in, V reference greater than V in म्हणजे V reference किती घेतला आम्ही? V reference आम्ही घेतला 0. 0 greater केन्ना जातलो? When V in is negative. If your V in is a negative value and V ref we have taken 0 volts, if that is the case in which your V ref becomes greater than V in, V ref कोणाक लायला? V reference लायला positive आक. So because your V reference is positive, your output voltage will be positive saturation, or V out is equal to plus VCC. Okay, is this clear? When V in, that is input voltage, is greater than V ref, because V in is connected to negative terminal, you will get output as minus VEE. And when V ref is greater than V in, when this input voltage V reference is greater than V in, you will get plus VCC. Okay. So this is the basic principle of op-amp as zero crossing detector. Okay, this is how it compares. Okay, now what are the applications of zero crossing detector? It is used as a sine wave to square wave converter. We will see in the next slide how is it converting sine wave to square wave. Okay, with this basic principle, sinusoidal wave that is applied here at the input terminal gets converted as a square wave. So this sine wave you will get at the output as a square wave. We will see how do you get that as a square wave. So this is a sine to square wave converter. Also it is used in phase meter. Phase meter meaning to check what is the phase of the signal. Okay, whether it is 0 degrees, 180 degrees, 90 degrees, that is phase meter. Also it is used in frequency counter to count how much is the frequency of the signal. These are some of the applications in which op-amp is used as zero crossing detector, or a zero crossing detector is used. Okay, so far are you clear with what is the basic principle of operation of zero crossing detector? How is the circuit? What configuration we have taken here? Negative or inverting configuration of op-amp. Okay, and these are the applications. Now let's see what are the waveforms, or let's see how the sinusoidal voltage is getting converted to square voltage. Okay, this is the circuit, the same circuit I have taken here. Okay, this is negative terminal or inverting terminal to which our input is connected. Then this is positive terminal to which reference voltage is connected, which is equal to 0 volts. Fine. Now let's see how are we getting this output. Okay, this is our input waveform. This is the input voltage V in. So this is your input waveform sinusoidal, and at the output you are getting square waveform. So sine waveform is getting converted into square waveform. Okay, so that is why it is called as sine to square wave converter. Let us see how this magic is happening. Now we have taken this V reference is equal to 0 volts. 0 volts is nothing but your x-axis. So this is your V reference 0 volts. Okay, this is your 0 volts. Here's the V in. Before that, yeah, V in, let's take it as 2 volts peak to peak. So suppose your V in, this is your V in sinusoidal. This we have taken as 2 volts peak to peak. 2 volts peak to peak म्हणजे पॉझिटिव्ह पीक असते 1 volt, नेगेटिव्ह पीक असते 1 volt. So total from positive peak to negative peak we are getting 2 volts peak to peak. Okay, so input voltage is 2 volts peak to peak. Fine, and reference voltage is 0 volts. Now what will we do? We will do comparison, or the op-amp will do comparison. Okay, now consider only this interval. Okay, only consider this interval. This interval म्हणजे कोणचा interval? From 0 to this much, 0 to pi. Okay, 0 to 180 degrees, or only consider the positive half cycle of the input signal. What should happen? I have told you, if the input voltage is greater than the reference voltage. Input voltage खंयची पॉझिटिव्ह आसा ती इनपुट voltage आणि reference खंयचो वो straight आसा तो x axis आसा तो reference voltage which is your 0 volts. Okay, now if you see here, your reference voltage is 0 and your input voltage is plus 1 volt. खंयचो व्हडलो जालो? plus 1 volt व्हडलो काय 0 व्हडलो? Obviously plus 1 volt is greater. Okay, so as per your principle of operating of your zero crossing detector as a comparator, if V in is greater than V reference, where it is happening, so see this, V in which is positive is greater than V reference, what is your output? V out is equal to minus VEE, that is this voltage, whatever is the voltage applied here. So because your V in is greater than V reference, V in वयर आसा, V reference सकयल आसा, or V in 0, V reference 0 asa, V in asa to 1 asa. Okay, so in this case this is satisfied. V in is greater than V reference, so V out is minus VE. So what will be V out here? Minus V saturation, which is nothing but minus VEE. Clear? Hangasar V in asa to व्हडलो asa as compared to V reference which is 0. So that is why your output is minus VEE. Fine. Okay. Now let's consider this interval. Okay, what we have seen, if V reference is greater than V in, then V out is equal to plus VCC. So consider this interval from pi to 2 pi or 180 degrees to 180 degrees to 360 degrees, or this is your negative half cycle. So आता input voltage किती झाली? Input voltage झाली negative value, and what is your V reference? V reference is 0. Now tell me, 0 is greater or negative value is greater? 0 is greater than the negative value. Okay, now because your V reference is greater than V in this case, what will be your output? Output will be plus VCC. So in this case output will be plus V saturation. Okay, again here in this interval, positive half cycle, V in is greater than V reference, that is why you are getting minus V saturation, that is minus VEE. Again here your V reference is greater than V in, that is why you are getting plus V saturation, which is plus VCC. Okay, so this is as simple as that. This is simple. I have explained you in this video with negative or inverting configuration. If it is given in non-inverting configuration also, you should be able to explain this. Okay, if you have understood this, you will also be able to write the answer for non-inverting configuration. In the IT I will ask non-inverting configuration. So what you do is you try the non-inverting configuration, you try to mount the you try to draw the waveform for non-inverting configuration. Okay, if there is any doubt, let me know. If you cannot draw it, ask me. Okay, so this is the basic thing you need to understand here in case of op-amp as a zero crossing detector. It is basically a comparator that compares the two inputs connected at positive input terminal and negative input terminal, and the reference voltage is taken as 0. Okay, just for your information, I'll tell you, op-amp is also used as a simple comparator where there will be two inputs. In place of V reference as 0 volts, we can also take V reference as any other value. If any other value is taken, then it is not zero crossing detector. Only when your V reference is 0 volts, only then your op-amp is zero crossing detector. In place of this 0, if we are using any other DC voltage, any other value of DC voltage, then it is simply a comparator. Okay, which is not included in your syllabus, but I am just telling for your information. Okay, so this is our op-amp as zero crossing detector. Thank you.